Today I'm going to cover lesson 1-4 notes, and this lesson covers angles and angle addition. So let's get started. A ray is a part of a line. Ray we've covered before in our undefined terms. And recall that it has one endpoint and extends indefinitely in the other direction. Let's name two rays in this angle that you see to your right. One of the rays is going to be right here. It has the endpoint A and it extends in the B direction. So we're going to call that ray AB. And the other ray is going to be ray AC. Okay, so let's go ahead and label this. If two rays, well, let's label it later. If two rays have a common endpoint, as you see here, and extended opposite directions, they are known as opposite rays. So if one was going to the left and one was going to the right, two different directions, then they would be forming a straight line. So two opposite rays form a line. Opposite rays form a blank angle, that would be a straight angle. And a straight angle is defined as measuring 180 degrees. If two rays have a common endpoint and do not make a line, then that means they must form an angle. And that is what you see here in the upper right of the page. So they form an angle. The rays are the sides of the angle. Oops. So right here and right here, you have your sides of the angle. And the common endpoint is called the vertex of the angle. So the vertex would be right there. The angle above can be named angle A because the vertex is point A. It can also be called other names, such as angle BAC, or the other way around, angle CAB, or it can be simply known as angle 1 because there is a 1 inside of the angle. So 4 different ways you could call this angle above at the top right of your page. So here's another angle. In example number 1, we're asked to name all the angles that have R as a vertex. So let's pick the smaller ones first. We can call this angle 1 because it has angle R as a vertex. Point R as a vertex. Angle 2 is another one with R as a vertex. Angle 3. And those are the numbered names for those angles. We could have also called them angle 1 could have also been called angle SRP. Angle 2 could have been called PRQ, angle PRQ. Angle 3 could have been called angle TRQ. And those are the small angles. We could have also gone for the bigger angles, which would be SRQ. That's combining angles 1 and 2. SRQ would have been one of them. So angle SRQ. And the other big angle would be angle PRT. Those are all the different angles. You could reverse the order for any of these if you wish, but they're still going to be the same angles. Okay, going down to number 2, name the sides of angle 1. Well, the sides are formed by different rays. One of the rays is going to be ray RS. And notice, even though S is on the left side here, S is the side that continues indefinitely. So we always draw the ray symbol going from left to right when we write a ray. So we're going to start at R and go. R is the endpoint and S is the side that extends. So ray RS. And the other side of angle 1 was ray RP. Continuing on to number 3, name the vertex of angle 4. Angle 4 is right here, so the vertex would be right at point B. Name the sides of angle BDC, which is another name for angle 2. That would be, these are segments this time, so we could say segment BD and segment DC. Those are the two segments which form the sides of that angle. And write another name for angle DBC. DBC is angle 3 in this case. And what's another name for it? That is the other name, angle 3. Okay, so some vocabulary here, talking about right angle, acute angle, and obtuse angle. These are definitions. A right angle is an angle whose measure is 90 degrees. And if you want to see an illustration, we usually will write this little square in the angle to indicate that it is a right angle. It's a 90-degree angle. An acute angle has a measure less than 90 degrees, so it doesn't open up quite as much. Here's an example of that. 90 degrees, less than 90 degrees. So that would be a less than 90-degree angle, an acute angle. An obtuse angle, on the other hand, is going to have a measure greater than 90 degrees, but less than 180 degrees. So as an example, you could say something like this. So its measure is greater than 90 degrees, but less than 180 degrees. Okay, so those vocabulary words you will need to know very well. Angles that have the exact same measure are called congruent angles. And notice the arcs on this diagram. Two of the angles have a single arc. The 65-degree angles have a single arc. And the other two angles have double arcs. If they have the same number of arcs, then that indicates that they're congruent angles. So, something you should keep in mind. So, just looking at this figure, which are the angles that match? You could say, well, we know the measure of angle ABC, and this is how you write the measure of angle ABC. You put a little m in front. The measure of angle ABC is equal to the measure of angle, where were we? ABC and DEF. It's equal to the measure of angle DEF. So, if two angles have the same measure, that means they're the same size, and the angles are congruent. So angle ABC is congruent to angle DEF. If they have the same measures, they're congruent. We knew that because they both had 65 degrees, and we also knew that because they both had single arcs. For the other angles that have double arcs, we can say angle CBE and angle DEB have the same number of arcs. So that means they're congruent. Angle CBE is congruent to angle DEB. So this is really getting into the next page, but just like we did segment addition in the previous lesson, you can also perform angle addition. And remember, anytime you're doing segment addition or angle addition, part plus part equals whole. So we're going to cover that on the next page. This gets into the angle addition postulate. And if you look at the diagram, it's fairly clear. If point D is on the interior of angle ABC, then it's going to be in the interior if and only if the measure of angle ABD plus the measure of angle DBC is equal to the measure of the whole angle, ABC. So that's really another way of saying part plus part equals whole, which we learned in the previous lesson. In this case, you could say, well, this is one part, this is another part. Here's another part, and then the whole thing, I will write in a different color. The whole thing goes all the way across to include both of them. So part plus part equals whole. And why don't I just write that? Part plus part equals whole, just like over on this side. It is helpful for this lesson if you do have multiple colors of pens or markers, because there are so many different things going on. In the figure to the right, moving on, ray KJ and ray KM are opposite rays, which means they form a straight line. Now, there's going to be two different problems, number 6 and number 7, that both make use of this figure. So I'm not going to mark it up for the first one. I'm going to try to save my figure for the next time around, since I don't have a pencil that I will use to erase. But let's read it first. If the measure of angle NKL, that's this angle right here, and the measure of angle LKM is 38 degrees, one is 67, one's 38, what is the measure of angle NKM? Well, this is just going to be part plus part equals whole. We can say the measure of angle NKL plus the measure of angle LKM is equal to the whole thing, which is the measure of angle NKM. Part plus part equals whole. Now fill in what they told you. They told you that the measure of angle NKL was 67. The measure of angle LKM was 38. And that is going to be equal to the measure of what we're trying to find, which is angle NKM. And what does that equal? 67 plus 38. The measure of angle NKM is going to be equal to 67 plus 38, which is 105 degrees. So that is the answer for number 6. Number 7 is the last time we're going to use this figure, so I'm going to go ahead and mark it up a little bit more. If this time the measure of angle NKL is 9y plus 15, NKL. So I'm going to say that's 9y plus 15. And the measure of angle LKM is 5y plus 2. And I know the whole thing together, the sum of those two together, is angle NKM, which covers 115 degrees. We need to find both y and then find the measure of angle LKM. So let's write our equation again. The measure of angle NKL plus the measure of angle LKM is equal to the measure of angle the measure of angle NKM. Okay, and what do we have that we can fill in? We know NKL was given as 9y plus 15. And then the measure of angle LKM was given as 5y plus 2. And the measure of angle NKM was given as 115. So this is our algebraic equation that we can now solve. Combine your like terms. 9y and 5y gives you 14y. 15 and 2 gives you 17. And that is equal to 115. Subtract 17 from both sides. And you get 14y is equal to 98. And once you divide by 14, you get y is equal to 7. It says find y and find the measure of angle LKM. Well, we already found y. Now the measure of angle LKM was given as 5y plus 2. So I'm just going to plug in what I know for y. 5 times 7 plus 2, which is equal to 35 plus 2. So the measure of angle LKM is equal to 37 degrees. These angles are all going to be in degrees as their units. Okay, so some more fill in the blanks. A ray that divides an angle into two congruent angles is called an angle bisector. That is our new vocabulary word. So in this figure on the right, angle ray PN is the angle bisector. The angle bisector of the bigger angle MPR. And notice we have the same number of arcs for these smaller two angles, which means they're congruent angles. And the only way that would be possible is if ray PN was indeed the angle bisector of the larger angle MPR. This, recall, this symbol is the symbol for congruence. So we can say angle MPN, the one on the left, is congruent to angle NPR, the one on the right. And you also knew that from the arcs, like I said. So the angle bisector means the point on that ray, point N in this case, must be on the interior of angle MPR. It's possible that sometimes you'll have points that are on the exterior of the angle MPR, such as point Z. So I'm going to draw point Z here, and notice point Z is not inside the angle. So point Z is not inside the angle right here. Okay, let's go down to the bottom figure. In the figure to the right, ray QP and ray QR, QP and QR are opposite rays, so they form a straight line at the bottom. And ray QS bisects this other angle, PQT. So what I would recommend, since they're bisecting, I would draw some little arcs, and you want to draw them a little staggered, because otherwise it looks like one big arc if you draw them right next to each other. So this means if ray QS bisects angle PQT, you have two resulting angles that are congruent to each other. One of them is angle PQS, and the other is angle SQT. So again, we're going to have two different problems make use of the same figure. I'm going to try not to mark it up the first time, because that would confuse us for the second time. If the measure of angle PQT, that's the bigger one that got bisected, is equal to 60 degrees, angle PQS, that's one of the smaller ones, half as big, is equal to 4x plus 14. What is x? That's what we're trying to find. So we can say that smaller angle, PQS, had a measure of 4x plus 14. If I were to double the size of that smaller one, I would get the size of the bigger one. So I'm going to do that. Double the smaller angle. So I'm going to double 4x plus 14. And that gives me the measure of the bigger angle, PQT, which was given as 60 degrees. So this is my equation that allows me to solve for x. If you want, you can distribute the 2 first. That's not a bad idea. 8x plus 28 equals 60. Subtract 28. You get 8x is equal to 32. Divide by 8. X is equal to 4. And that was what we were asked to find. What is the value of x? So, just remember, the bisected angle is going to be half as big. So if you want to relate the bisected angle to the original bigger angle, you have to double the bisected angle to get the measure of the bigger angle before it was bisected. Okay, moving on to number 10. If the measure of angle PQS is equal to 3x plus 13, I'm going to write that out here, 3x plus 13. And the measure of angle SQT is equal to 6x minus 2. Find the measure of angle PQT, which is actually both of those added together. Well, all we know is, as we conveniently drew earlier, they have the same number of arcs because the bisector means these two angles are congruent to each other. So angle PQS is congruent to angle SQT. That means they have the same measures. If they have the same measures, we can set them equal to each other, which is what I will do now. 3x plus 13 equals 6x minus 2. Solve for x. I'm going to subtract 3x from both sides. 13 is equal to 3x minus 2. Add 2 to both sides. 15 is equal to 3x. Divide by 3. 5 is equal to x. That is not what we were asked to find, but we do need to know that x is equal to 5. Now, you have a couple of choices here, but recall that we're looking for the measure of angle PQT, which is exactly twice as big as either one of those. So you can pick whichever one of those you want. I'm going to say the measure of angle PQT is equal to twice the measure of angle PQS. Sorry, I ran out of room there. So the measure that we're looking for is equal to twice the measure of angle PQS. Well, what is twice the measure of angle PQS? Twice the measure of angle PQS was given as 3x plus 13. And I know x is now 3 times 5. And I know I have 2 sets of parentheses here, but work from the inside out. 3 times 5 is 15, plus 13, which gives you 2 times, 28. So the measure of angle PQT is equal to 56 degrees. So you could have just substituted x in for here, gotten 28, and then doubled it at the very end. That would have been another way to do it. 28 degrees is the measure of one of the smaller angles. When you double it, you get 56 degrees. And that concludes our notes for today.